Now we have some examples of polynomials which are difference of squares. This is difference of squares. Something is square minus something is square. That something is A, the first something. The second something is B. So in example 1, x4 is the square of what? x4 is a perfect square of x square. So this is our first something. You can say it is A. Now what is 81? 81 is a square of 9. So it means the second something is B, which can be denoted by B, is 9. So now we can write this x4 as x2 square. You can write it like this, minus 9 square. So now compare with this, something square minus something square equals the first variable, which is A, or first something, plus y, the second something or the second variable, multiplied by x minus y. So our A or our first something is x square. So we can say that this is equal to x square plus 9 and x square minus 9. So we have come from this side to this side. We got two terms which are square of something and which are being subtracted. So we have a difference of two terms squared. So this is called difference of squares. So difference of square equals first term plus the first variable plus the second variable multiplied by first variable minus second variable. So you have to keep the order in this, the second term, x minus y. You cannot write y minus x because x minus y is not equal to y minus x. So whatever order is here in difference of square, the first one, because this is not equal to x1 minus x raised to the power 4. So these two are not same because the sign is reversed here. So therefore the order is important. Now the second example, 9x square is square of 3x. 3x square minus 64y square is the square of 8y. So now I'm not writing a, b, anything. I'm just writing straight away 8y whole square. So something square minus some other thing square equals, in one bracket add both things, 3x plus 8y. In the second bracket we subtract second from the first. So these are our factors. Very simple. So difference of square is the most simplest form and the most easy, which students normally don't make any mistake. So the third one, x square is the square of x, of course, minus 121 is the square of 11. I already mentioned to you that you should be able to recognize the square of up to 20 numbers as a math student. So now we have difference of difference of square of two things, two variables. So we just, in one bracket we add both, x plus 11, and in the second bracket we subtract second from the first. So this is our answer. Example 4, x6 minus y6. So let me do this example on this side. x6 minus y6. Now x6 is the perfect square of what power of x? X cube. If squared, the power of the power always multiply. index laws. Otherwise, you can watch the lecture of index laws. So x cube square minus y cube is square, whole square. So now we have difference of squares. Something is square minus some other thing is square. So we add these two things, two variables. First variable is x cube, second is y cube. So we add both x cube plus y cube, and then we subtract second from the first. Order is important. So x cube minus y cube. So now we got this factored form. Now at this stage we have to check whether it can be factorized further or not. And if you look carefully here, we have x cube plus y cube. We have a formula for that. We have an identity for that. That x cube plus y cube is equal to this, the product of these two terms. So although this is a factored form, but because both of these can be factorized further using sum of cubes and the difference of cubes, this is difference of cubes and this one is sum of cube. So therefore we will factorize these two, and instead of x cube plus y cube we can straight away write these two terms. So in the next step what we do, x cube plus y cube, we write x plus y multiplied by x square minus xy plus y square. This is for this term. Now for this term, we use this formula. X minus y multiplied by x square plus xy plus y square. Now, although I don't recommend memorizing things, but there are few things which you will eventually memorize, and these identities are one of those, because these identities occur so many times in your career that you eventually try to, even you don't try to memorize, you will memorize these identities. So better you just memorize these things, that x plus y, x square minus xy plus y square, and the difference of cube is whatever is the sign here is in the first bracket, and then the first sign is opposite, and the last sign is always plus. So you can memorize whatever you want, because these are so commonly occurring identities that you have to solve these during your exams or during your competitive exams. So we have utilized all these three identities in this example. So this was a good example. So this is how you solve problems which can be represented as one of these identities. In exam, it's not necessarily that you will be given that these polynomials are difference of squares. You have to figure out by yourself which is the best formulation of the problem you can have for this particular problem.